Chapter 14, we're going to talk about inheritance. Inheritance is one of the hallmarks of OOP. When we think about object-oriented design, how to structure your code to solve a problem, and in terms of objects. The one of the things that we think about, obviously, is not just a bunch of disjointed uh, objects, but they are somewhat related because of obviously they're in this problem domain you're trying to solve. And it's very likely they have some kind of relationships, these objects. They're not just some kind of random separated. So inheritance is one of the ways the objects can be associated with each other. Not the only way. But let's take a look at some of the concepts. So first is the class hierarchy. So here's a simple example. We have, let's say, a box class, and then that is uh, used as a base class to carton. So essentially, carton inherits from box. We have dimensions of a box, and then carton is a specific kind of box that is made from some kind of material, which, maybe cardboard or whatever material it might be. And then you may have different kinds of a carton. Basically, depends on the content that's inside the carton. You may say you have a food carton. So they may have an additional contents variable that's differentiating food carton from a general carton. So this is a sort of hypothetical example. In the real world, you're going to see a lot of these examples, just like what we're seeing here. So it's not uncommon to see the relationships among the objects that you are trying to use to solve your problem. So now this is basically the textbook's own way of drawing a diagram among the objects or classes in this format. But you're gonna see later, I'm gonna show you also another way of drawing the relationships among the classes. That's more of a standardized way. But these things are kind of intuitive here, as you see. So when you have a carton, inherits, basically extends, sometimes we'll say extends from box, and it inherits all its members. So including member variables, of course. And typically, when you have an inheritance, this derived class also has its own members, maybe member variables, maybe member functions, whatever. There should be something that differentiates from the base. And of course, that chain of inheritance can just keep going, if that makes sense for your problem. And so here's another way to look at the relationship between base and derived classes. So you have a base class that has member functions, member variables, right? That's what you have seen so far. So now let's say we have a class, we don't want to redefine everything. There is a relationship. So we are going to derive this class from the base class. So essentially, this derived class contains, if you make an object of the derived class, that as if it has a sub-object of base class. So all these members are inherited. Now, whether all those things are accessible, that's a different question. We're going to look at that. There's some control, how you can control the accessibility of the members from your derived classes. But basically, they are still technically all inherited variables or functions. And then, of course, derived class has its own functions or variables. And the inheritance is essentially can be looked at from this diagram, which is a UML, Unified Modeling Language. You're going to see more of it when we talk about the design patterns. And here, just a simple example. This is drawn with a software called a Plant UML. And so what you do is now for the if you want to, by the way, so let me go back to this, right? So I have actually the source code um, for this diagram right here. As you see, let me gonna show you, preview this right here. Okay, so that is the diagram that you see over here. Now, this is essentially the source code that draws this, and this is using this software called the Plant UML. And what you do is now for Mac users, you install this Plant UML extension. So this extension from this developer Jeps, and then you install this in your Visual Studio Code. And then you also have to install this two more things: install Java and GraphViz. Okay, use the homebrew that you already have this installed by virtue of installing the previous software for this class. So that's for the Mac users. Now, if you're Windows users, there is also a plugin for Visual Studio. Okay, so in Visual Studio, you just search in extensions. Then there is this, just search in Plant UML, you'll see a extension. There's only one, Plant UML language service. So you just install that thing. That should also allow you to render the source file for Plant UML that will draw a UML diagram. And now, so of course, what you see here is essentially just a one type of diagram. UML supports many different kinds of diagrams. This is called a class diagram, and perhaps it's a sort of most commonly used, and because when you do OOP, this is sort of a very fundamental thing you have to do. And so we communicate through diagrams. You're going to see a lot of drawing like this. So this is, of course, there's a circle with a C inside. So this is a class. There's a name of the class. And then you see there's sort of a three sections in this box. And then the section below the class name, those are the member variables. And you see a red squares here that indicate they are private, and there's going to be different colors and shapes for different access specifiers, the different visibility, right? So there's another section below that is going to be where the functions are, the member functions. So you see this relationship here, this empty arrow here. This empty arrow indicates this is the inheritance relationship. This cotton inherits from box. So box is the base of cotton. Cotton is derived from box, right? And the cotton has its own member material. And of course, those things are inherited by cotton. But of course, you don't really declare those things again in cotton, but they're just automatically, inherited. Okay, so this is that. Real quick about this. So inheritance sometimes can be called is-a relationship. We can simply say, because cotton inherits from box, we say cotton is a box. So that kind of, when you say cotton is a box, that also indicates you can actually assign an object of cotton to a variable of box because cotton is a box. So that is always allowed and legal. And then if you want to do the other way around, then we're gonna talk about that in the next chapter about polymorphism. This is that's a when you have, let's say, a box, you have different kinds of derived classes from box. And by the way, in some language, they call subclasses versus parent class or superclasses. So there's a lot of terminology to describe this relationship. But in C++, the standard way of saying this is a basic class, this is derived class, and this is still inheritance relationship, okay? And this word here, public, next to this base class, this is the base class access specifier. We're going to explain a bit more about this. But then let's take a look at some other relationships too. Aggregation. So inheritance is not the only kind of relationship between the objects. You can have aggregation relationship. So what's aggregation? Aggregation is also can be considered as a has a relationship. Let's see, if an automobile has an engine, it has a transmission. And this has a relationship, it does not indicate there's ownership, okay? So basically, it kind of means that automobile, well, of course, this whether you use aggregation or not, that kind of really depends on the problem, the way you model your problem. It is not absolute, right? So it really depends on your specific problem, how you want to model the things, the objects. So let's say in your particular problem, your engine and transmission, they are going to be standalone objects too, not only because they are part of an automobile. The automobile, has a sort of a relationship with the engine and transmission. They are sort of is an aggregation, but automobile does not own these objects. So essentially, that also means that automobile is not responsible for the construction or destruction of these objects. But automobile may have variables, member variables that are engine, but maybe there's one engine, there's one transmission for an automobile, right? But if the automobile is destroyed and this engine and transmission, they still stay. So that's really what this aggregation means. And another example is this. Uh, so a professor teaches, this is the multiplicity label here. It means that one professor teaches one or more classes, okay? So let's say that's somehow relevant in your particular problem. That's what you're trying to model. So the professor may now kind of just, how is this relationship manifested in terms of the C++ code, the class, right? So it may have a member variable called classes, and which may be a vector of a shared class. Now, this shared class essentially just indicates maybe you're using let's say we're using a shared pointer, the shared pointer, smart pointer, shared pointer of class. And that also kind of is the indication that it's not responsible for the destruction of a class. The class could, exist outside of a professional object, right? And then, of course, the class may also similarly have, a vector of students, and that also the students could also exist without classes. So it obviously depends on your problem domain, whether that modeling makes sense, right? So this is not absolute, it's not 100% just like, okay, what the real world is like, right? But it really is not, restricted to your particular problem, what kind of relationship makes sense. So it's really problem specific, okay? And then related to concept, which can easily get confused, is this composition. Now, composition is also has a relationship. So, now for example, house has a room. A person has a head, has multiple hands, maybe like one from 0 to 2, maybe, right? Or legs, similarly. The This particular relationship though is stronger than the aggregation in the sense that it implies ownership. A house, actually, object owns a one or more room objects. If the house is destroyed, the rooms should not exist, right? So it's these rooms are not really shared between houses, right? So that really kind of what comes down to is this house object will be responsible for the construction and destruction of the derived objects, right? This is not derived, sorry, from these objects that are associated in terms of the composition relationship. So what it comes down to is this house is going to have a member variable, let's say, of maybe a vector of rooms, and in this case, it may not be a shared pointer. It may not be a pointer. It may not be a reference, right? It will be just a whole object that's owned by house. If a house is destroyed, those objects will be destroyed. So members cannot exist outside the container. We can think of this as a container that contains these objects. Okay, so it's in the inheritance relationship. If you recall, if you have derived class that inherits from a base class, and essentially the derived class has sort of a sub-object of a base type, right? It's also kind of, in a sense, that it contains it. It has maybe more stuff, more data, but it contains. So just in general sense, that's what I mean. A container in terms of the object contains the other type of object. So the house contains rooms, and the person contains head, hand, and leg. Okay. So hopefully that's clear. And by the way, the source code for these diagrams, and when you see this this style is the default style for class diagram generated from plant UML. They are in the repository. You can check them out. Okay. So I mentioned about there's a earlier there was a public specifier along the base class. So when you declare a derived class that derives from a base class. So you basically have let's take a quick look at an example, right? So this is, let's say, right, this is a quick example. So you have a carton, right? And that is derived from box. And so there is this word here, this obviously you're familiar with, the public, protected, or private. This is the access specifier that Y is using in here. This is in this particular context, what does this mean, right? We've seen where it's used for members, specifying the member accessibility, but what does this mean in front of the base class? So, so these are called the base class access specifiers. And so this chart makes it pretty clear. If you use a public, right? So in the case of here, this is probably the most common, that's sort of the default thing you're going to use. If your base class, these are the members in base class, or you may have public, protected, private members, right? And that's what you are familiar with so far. And what's happening when you use that public keyword here, and then the derived class essentially won't be able to access the public members and protected members, right? But of course, you will not be able to access private members. Right? Remember, private members are always private. Well, in the case of C++ language, it's kind of a little weird. The private members are accessible to friends, right? We talk about friends. You can have friend function, friend class, and those entities will be able to access your private members when you declare them as friends. So, but then not necessarily in some terminology, people call, you have a parent class, child class, right? For some reason, the parental relationship is not as strong as a friendship in C++. Okay, so you really want to, so that analogy doesn't really work very well. Okay, so you just have to understand those terms in the context of the language, how it's defined. Okay, don't try to draw too much into analogy in how the real world works. Okay, so the private members are private, cannot be accessed in the derived classes. Of course, not classes that are not even associated with the class. But then, so keep in mind though, they're still inherited. It's just that they're not accessible. Okay. And then what happens if you use protected base class, right? Let's say here we modify this to protected. If it's a protected class, that means that if the accessibility of a member in the base class, if that is a higher than protected, in terms of, like, for example, public, it's higher than protected, then that will be downgraded to protected in the derived class. So that also in the sense that means these members are they have become protected members. So if you have an object of derived class, you cannot access these members anymore because they are protected, not public anymore, right? Or if you have another derived class that derives from this derived class, they can still access the protected members, right? So, but then if it's a class, is an object that's not associated with the class, they cannot access the protected members. Private members remains the same. As I said, private members are private. They don't get inherited. Well, they don't get accessibility in the inheritance chain. They're still inherited. So what if you use the most restrictive one called the private? Let's say I say private box. That private means anything above private. You got public and protected members. Those things that are sort of higher accessibility level, they will be downgraded to private. That's really what that means. Okay. They downgraded private in the derived class. So if you got another class that derives from this class, then they cannot access these private members, right? So we know private things are private. Hope that's clear. Now, how do you remember all of this, right? So really, it's only a couple of things. There's a couple of rules you remember. First of all, private members are always private. They will not be accessible along the inheritance chain. And then when you have a access specifier for the base class, this is the base class access specifier, essentially means that any any members in the base class that are higher accessibility will be downgraded to that level. Okay. Well, if you use a public access specifier, nothing will be downgraded because public, that's the highest. I mean, that there's nothing higher than public, so there's really no change, right? You see, that's the default you probably will do most of the time. So the access specifier in the base class, they are just carried along, no change. Okay. Of course, private members are private. These are they're out of touch. Okay. But we're talking about the ones that can be accessed in the derived class. So then if that label is private, that means the ones that are higher, protected and public, will be downgraded to private in the derived class. Okay. Those members are inherited, but they're going to be private now in the derived class. Okay. So that's really, I hope that's kind of simple to remember. Now here's another way of seeing this. So recall the base class really is like a sub-object inside your derived class. It's not very accurate when we talk about class as a sub-object, but we're talking about objects of derived class. An object derived class contains an object of the base class, a sub-object, essentially. It's got its own members, most likely. And the public and protected members, those members are going to be always accessible in the derived class. Okay, we're talking about, can we access those members? Yes, you can access those members, not the private ones, obviously. Private ones are never accessible. But the public predicate, they are accessible in the derived class. Well, they're accessible, but then these access specifiers, are they retained effectively in the derived class, or are they modified? Okay, they can be modified, as I said. If let's say you use the private base class access specifier, those groups of members will be downgraded to private in the derived class. And how does that affect? That doesn't, the accessibility is not affected in the derived class, but it will be the effect is on, when you access the members of the derived class, right, from outside the inheritance chain, or from another derived class that derives from this derived class, and that's when the effects will be shown, right? Okay. So let's look at the case where you have another class that derives from the derived class. So as I was just saying about, let's say you have a derived class that's, you're using the protected access specifier for the base, right? Protected base. Really what that means is these members, so because it's protected, that means the public members in the base will be downgraded to protected now, okay? So the public members are effectively protected now. Protected remain the same. And these two groups of members, they can still be accessed in another derived class that use this derived as a base, okay? Now, private is simple, okay? Private means private, they cannot be accessed in the derived class, okay? So you see how that works here, okay? So they inherited may be accessible. Why is that? Well, why is it not always accessible? Because you can actually stop the inheritance chain. We're going to talk about that a little bit later. That is, there's another way. Let's say you don't want the class to be inherited. Like say, this is the last of the chain. You can do that if you want. Or you can make certain members not inheritable, right? So that is essentially the final specifier. We're going to talk a little bit more about that later. So this is essentially, that's the rule here. And then of course the private case, if you have a private base access specifier, and remember the public and protected members will be downgraded to become private now in the derived class. Now basically everything is private, so they cannot be accessed in another derived class that derives from this derived class, right? Okay, hope you're not getting confused. So how do you choose the access specifiers for the base class or anything, right? So there's the access specifiers, you use it as for the base class when you are inheriting from it, or of course you also have that to specify the accessibility of your members. So kind of a couple of things that just kind of general guidance. You want to use private member variables. So the member variables should always be private. And the member functions, if they are not part of the public interface, we'll talk about interface, that's basically the public from the objects that are not associated with the class that whatever they can access the public interface, of course. If the member functions are not supposed to be public interface, then you have to think about, okay, do you want access from a derived class? If you want that, you make those member functions protected, otherwise private. Okay, so to limit the public interface from a derived class. So now, because the base class access specifier, the way we can use it, that really allows us to control the public interface of the base class, essentially, in the derived class. So let's say somehow we don't like the interface in the base class. Maybe it's too broad. Now we want to limit it to make the class a little safer to use. Or you wanted to redesign these things to help, and then you have to migrate the clients or the consumers of your code to the new code. So what you do is you may derive a class from that one you're trying to deprecate, and then you sort of limit the public interface to the set that you actually want. You want to get it right. And then you mark the base class deprecated, and then you give the consumers a bit of time. And then once they move over, then you can merge the base with the derived. And now you got this new public, more limited public interface that you wanted, right? So how do you do that? Because we know, okay, you can use the protected or private interface, private access specifier for the base. But then when you do that, it's like you can't pick and choose. Like it's the whole thing will be somehow limited, as we just saw, the downgrades, right? But you can make an exceptions. And what you do is using this using declarations. And we have seen using in many different places. Using is very versatile in C++. Now, this what you do is you have this using declaration. Here's an example. You are saying, well, okay, well, I don't like the public interface of a box. I'm going to limit, okay, got too many things public, and now I'm going to just replace it with a cotton. And but then I still want that volume function to be carried over, okay? But maybe not the other things. So then you use using and bring this volume to this cotton scope. Now remember, every class starts a new scope. So you can use the scope resolution operator to access the members in the inheritance chain. And sometimes this is necessary to disambiguate, because the compiler cannot figure out which one you're choosing, because there's multiple choices. But here we're using this to inherit a particular member from the box, from the base, and then put that in the public section, right? The public access section. So this could be all the overloaded functions of a volume. As you see here, is not the function signatures here. We're only using the function name. That means all the overloaded function for volume will be inherited as a group. So this is basically, it's a package deal. You can't just pick a portion of the overloaded functions. This is how it's designed. It kind of makes sense also. Okay. And then what happens to constructors? How do you construct a derived object? Well, what's happening is the constructors will be invoked along the chain of inheritance from top to bottom. From top to bottom, what I mean by top to bottom, right? So you've seen this charts, the diagrams, that so far, the way we draw them, the base class is always at the top, the derived class is at the bottom. And this can go on if you have more classes deriving, right? So essentially it's like a inverted tree, upside down tree. This tree, it's this particular data structure, this is not a tree, by the way, but it's the shape of this diagram looks like a tree in terms of a data structure tree, not the real world tree. It's upside down, right? The root is at the top. So again, because of this just that kind of analogy there. So that's kind of what we're saying when we talk about, from top to bottom, really from the most base to the most derived. If your chain is long, it's not just, maybe you have a couple of them along the chain. We actually have seen this, right? Remember when we talk about the IO basics, in the standard library, the design of the IO library, those classes, there's a chain of inheritance, right? The IO stream, F stream, IF stream, or string stream. There's right all those things, and they inherit from the top. It would be the iOS base, or right that's so that's a kind of what you see. That's kind of fairly common. So the constructors are invoked from the chain of inheritance from top to bottom. So if you're constructing cotton, and then actually this is it should have inheritance here. So is it inheriting from box? That's missing here. So I'll fix that in the slides. But so when you construct a cotton, you need to also initialize the variables of a box. So you have to construct the base object too. Now there's a difference between the two, by the way. This is a regular constructor, right? And then here we're actually seeing a copy constructor. And either way, you have to remember that we're saying the base class is like a sub-object in this derived class. So that sub-object needs to be constructed too. You may also initialize additional variables. That would be fine. But the base needs to be constructed. So typically, you may just invoke the base constructor too to get those initialized in the initialization list. Okay. Now, there's a interesting thing about using declaration there. So here we're talking about using. You can sort of redefine the accessibility of a base class. Now, in the sense that you can downgrade. By the way, the only thing you can do when it comes to modifying the base member accessibility, you can only downgrade. You cannot upgrade, right? That's a basic rule. So public can become protected or private, but you cannot turn private into protected or public, right? So that's what I mean. You can only downgrade, not upgrade. So, but then when you use this using declaration on a constructor, the rule is a bit different. The access specifier of those constructors from the base, they remain the same. They cannot be modified. The access specifier of the base class does not impact the way when you actually inherit. If you do inherit them with this declaration, then the specifiers are going to remain the same. If they used to be, protected or public, they will not be affected. That's just kind of special rule with the constructors. How does destruction work? Right, the opposite. Well, it is the opposite process of a construction. So the order of destruction is from bottom to top. So from the most derived to the most base. Okay. So then look at this class hierarchy here. You got the box, and then you have a cotton that's derived from box. You have a foot cotton that derived from a cotton. And if you look at the sub-object, the depiction of the object relationship, you've got a sub-object of a box inside cotton, and then you've got the sub-object of a cotton inside a foot cotton, right? And another analogy of this would be thinking of it as like almost like an onion, in terms of a destruction process, you are peeling the onion. So you're essentially destroying the members of a food cotton first. There's the most outside layer, and then you work your way in layer by layer until you get to the most base sub-object, and that'll get destroyed. The construction process is like creating the onion. You start from the innermost layer, and then you add a layer on top of that, and add another layer. So that hopefully also has a little visualization that helps you remember how this works. Okay. Then you can also inherit from multiple classes, if multiple bases, if you want. Um, so the multiple inheritance is a bit of unique in C++, and some languages do not allow this, but in C++ you can. Now, here's an example. Again, sometimes I would say some of the examples are maybe a little bit contrived, but that's fine. That's just for the purpose of understanding the concepts. Now, because a real world example may be way too complicated, that can distract you from learning the real essence of what we're trying to convey. So this cereal pack, let's say we have a cereal pack that is both a box and also a food container, or both a carton and a food container. And the carton is a box, right? You see this relationship here. So this is the most that derives from both carton and food container. And carton also derives from box. Okay, so this multiple inheritance is also allowed. Now, the example here, right? So the example 7B, so you look at this in terms of the actual example, then you see this is how you may look at how that might look. A serial pack inherits from, and you use a comma to separate this list of bases. And of course, each of the base get its own access specifier according to that rule that we explained. And of course, when you're constructing an object of serial pack, you got to take care of the bases too. See, you gotta initialize your carton object, also the food container sub object. Okay. And then you see an example here. This is for illustration in the sense that the volume is a protected member of food container. And then we also said you need to make your members private, but this is essentially for illustration purpose here. And then shows you how to use that scope operator prefixed by the class name to disambiguate, because now you've got a volume function inside carton or from food container, which, well, this is actually, never mind, this is actually the member variable. Well, we know in real world, probably if you follow the convention, you use m underscore, and then it will not be a problem. But here's the illustration purpose. This is actually a member variable, a food container. If we got a function that also is called a volume from carton. So, and then you also can use the using declaration to bring the members of the bases into your current class scope serial pack. So that means if you do this, this is in the public section, that means this volume member function of this member function of a box, well, actually it comes from carton. So you see, you have two paths. There's a volume here in a food container. There's a volume here by virtue of a box, right? So this is another path. Which one is going to be if you call volume? Is it going to be the volume from box, or the volume indirectly from box, or the volume from food container if you call volume on serial pack? That's why there's ambiguity here. To solve this ambiguity, you use this using declaration. Say, well, what I really mean about volume is that's from carton. So you choose this path, okay? And then the get weight, similarly, it may have get weight from both carton, from food container. And then this will help you disambiguate. The compiler will be happy with, otherwise it will complain, okay? Because of this multiple inheritance, then it causes an issue sometimes. And this is why some language don't want to deal with it. But you know, in C++, you have clear rules and the way to solve this problem. So it is fine. And this problem is called a diamond problem. If you really stretch this out a little bit, this may look like a diamond, the shape of a class hierarchy. Okay. If we got the common at the very top, that is derived by box as well as food container. Maybe you've got some common stuff you want to put into that class common. I'm not saying this is a valid um, design, but we're making a hypothetical scenario here. And of course, you got carton that you derives from box, and you still got your cereal pack. That's both the carton and the food container. Okay. Now, what happens here is now the common comes with its own member variables, let's say, and then what happens is this is gonna be inherited along this two paths down to cereal pack. So what happens is your cereal pack will actually have two copies of a common, right? It's gonna have a common sub-object from this path through carton, box, common, or it's going to go through the other path where you go from food container to common. So that is not a good situation. You don't want that actually, right? How do you solve that problem? Then you use the virtual base class. So you're going to introduce a new keyword here, public virtual common. You use this for both sides. So you want to make this virtual here, they make this virtual here, and then the common by the way of using the virtual base class, then eventually your serial pack will only have one copy of common. So that kind of solves the problem. All right. So let's summarize this. So a class may be derived from a one or more base classes. So there's a single inheritance or multiple inheritance. The derived class inherits members from all of its bases that, private or not, they're inherited. But then can they be accessed? There's different rules that govern the accessibility. Access to the inherited members of a derived class is controlled by two things. The access specifier of the member in the base class and that of the base class in the derived class declaration, right? You got colon, you got public box or whatever. That is the base class access specifier. So, and then we have seen the rules how that base class access specifier impacts the accessibility of the members of the base class, okay? So, and then a constructor of a derived class is responsible for initializing all members of the class. So remember the construction process is building the onion from the most base to the most derived, okay, from top to bottom. That's how you construct. And then the creation of a derived class object always involves the constructors of all the base classes. So you have to cover all your bases. And derived class constructor should call constructors of its directed bases. And otherwise the base class default constructor is called. So that's the rule here. And it is essentially, you just have to, typically you want to call your base class constructors, the ones that you declare as direct. Then a copy constructor of a derived class should always call that of all directed base classes. So similar to the regular constructors, in your copy constructor, then you also need to construct this object through copy constructors of your bases. And then you can also use the scope resolution operator to qualify a member's name if that is ambiguous, right? When it comes to multiple inheritance or, you could come down to having a naming ambiguity. And how do you differentiate them? Because it won't compile if a compiler cannot deduce it. And then you help a compiler to understand what it is by using the fully qualified names. And that is basically right before the name and thinking of this as a part of the name. If you are accessing object with a dot notation and then a member function, for example, And then that member function's name, you need to qualify that with the one of the base class or specific class that can disambiguate with the scope resolution operator right there. It's a part of the name. Okay. So it may look a little weird, but that's kind of how it works. And then the versatile using declaration, and that way you can use is to inherit constructors. You can inherit constructors um, and to modify access spec of the inherited members. You can also use the declaration to inherit functions hidden by a derived class function with the same name but different signature. Um, if you don't do that, then it will basically that will be hidden. How do you access it? Well, you can use the scope, the qualified names. That's one way, but you can also use the use and declaration. Then it's gonna save you much typing. It's probably more intuitive because if that's what you intend, you're not flip flopping into different uh, situation. You know exactly what you want, and then you probably just want to use the use declaration, make this more permanent. Oh, by the way, we're here. This is the situation where we talk about same name, different signature. What happens to the ones that have the same name and same signature? In your derived class, you have a like say have a class have a function that's the same name and same signature as the base. That is the case we're going to talk about basically in another lecture. That's about overriding. You want to modify the behavior of the base somehow. You know the uh, same function. You want to now do something a little bit different, perhaps. So that would be an overriding concern. Now, the diamond problem through the multiple inheritance that can be solved by declaring the duplicated class. In the case of an example, we saw that common, right, base class. You can declare that as a virtual base class. That will basically resolve the diamond problem. Okay. All right. So that's what I have to share. Thank you.